Hello everybody, Tiago here. Welcome to my channel. This is another episode of my Go live streams URL shortener series where we are building a URL shortener from the ground up. Today, if I'm counting correctly, it's the third episode. And today we're gonna talk about SQL databases. So we have been writing this URL shortener for a little while now, and the data storage solution we have is a in-memory solution, so it's basically a Golang map, which means that every time we stop the application, the data is lost. Also, if you need to run multiple instances of the application, like multiple binaries, in the sense like if you're running on Kubernetes, multiple pods, or even if you run on real machine, virtual machines, every machine would have their own data independent of the others. So that's not very nice, right? The idea for today's episode is to introduce a separated data storage solution that's going to run outside of our Go application. And then every single instance of the application can connect to the same data storage. So all the data is available to all instances of the application running, right? To do that, one of the most easy solutions we have is just use a normal relational database like Postgre, SQL, MySQL, MariaDB, and etc. So that's the plan for today, to introduce a SQL database, and then let's see which changes we need to do on our application, how does it work, and everything else. So let's jump to the code. So last time we had some loggers. So just to start off, let's just look our main.go, our routes. We have go, echo, and rec and save. So let's just, for the sake of it, run the application and make sure that it's working, and then we go from there. Like, see how it's working right now, then dive into adding the actual SQL database, and then let's see what changes. So if I go, let's see, terminal, open my terminal. Okay, and then go run main.go. I should have my application running. Application running, port 3000. If I jump to my browser, actually, let's jump to the code for a second. I don't remember the query parameter for saving the URL. So you do save query URL. Okay. Jump back, and if I jump to my browser, no, yes, browser. I can do localhost 3000 save golang.org, and then you get a token, and then you can do localhost 3000 go to, and the token got, and they should be redirected to the URL that was the golang.org. So our application works. If you go back to a terminal, we have our nice logs. I mean, they're not the nicest, they're still in JSON, not console, but yeah, but the application works. So let's get back to our code. And the first thing I'm actually gonna fix the logs, because those logs in console, they're not, sorry, these logs in JSON, they're not the nicest to read. And I'll just by default log to the console and focus on the SQL database. And then if you have time at the end, I'll make it configurable via environment variable, like the port. So if I remember correctly, logger.output, I can set an output that's an IO writer, and then 0log has a log dot new console writer that should work nicely without any options. So let's see. And I think that returns a logger. Just oops, just equal. So that's should give us a nice console output. If you run again, we have a nice message. That's not a JSON, just a nice console output. We have the time. We have the level, like info for info, error for error, and etc. And have all our keys, like full bar that just set. If I just save a URL, we can see all the message, the things we set up, like request ID and everything. And it's way nicer to read than the JSON. We can make it configurable later if you want JSON or console. So when you run locally for development, we can use console. But then later on, if you deploy it to actual server, you can have it logging as JSON, and then you can ship those logs to a logging solution that can handle JSON nicely, like for example, Graylog, Kibana, or any other solution. Yeah, if you run it if you just get this code and run on your computer, you're actually gonna have different colors. My terminal is grayscale, so I have many shades of gray. But actually, like arrow is gonna be red, info, if I'm remember correctly, is green. So this zero logger library has actually nice features with coloring the output to make sure, like, to help to read based on the colors. But personally, I don't like it too much. I rather have the grayscale. So SQL databases in Golang. So if I go to the browser, if I get my shortcuts right, yes. So how do we do SQL databases in Golang? So Golang actually provides in the standard library a generic interface around the SQL databases, that is this database slash SQL, right? So this interface is going to provide lots of functionalities to work with databases, transactions, and things like that. But it does not provide you the driver to connect to the database. Sorry. And then actually lets the driver to be implemented by the user or their community, right? So there are many drivers to the most common databases, and they're going to work nicely with this SQL, database SQL. And the one that I'm choosing today is going to be this libpq for Postgres. So it's a pure Go drive for Go's database SQL package. So it supports most of the functions that we need, pretty much everything. It supports plenty of the Postgres specific functions and works out of the box, right? So we have your database. We know library. We actually need to run our database instance. How do we do that? There are many ways you can actually run a Postgres database on your machine, or you can even get a hosted solution. For the sake of simplicity, I'm gonna use Docker to start the database. So I have a terminal here, and actually I have some notes of the Docker command that I need to run. So what I'm doing here is, so I'm using Docker. Docker is like, the easy way to explain is like a very lightweight virtual machine, but in the end of the day, it's not a virtual machine. So it's technically not a very accurate description, but it's easy to understand. So for those that are not used with Docker, so basically it allows you to run whole applications in a fully isolated environment. And those applications running, we call them containers. So we start and stop containers. And then you can start a container and destroy a container at any moment. You can also have containers that persist the data. So you can stop the container, then restart it again, and the data is still there. That's what you're going to do for Postgres today, right? So without getting much into details with Docker, I'm just going to run Docker. So Docker run basically means run a container for me. I'm giving it a name. URL shortness Postgres. You need it minus ITU parameter just to be interactive. If you want to interact on the terminal with the application, just run Postgres not required, but I'll let it here so you have full access to the console and see the logs. I'm passing some environment variables for Postgres, and then that we can get into the documentation of the Docker container. Authentication method, I'm calling trust, which means basically accept every connection from everybody. We just run it locally for development, so we don't really need to worry about credentials. I could set up the proper credentials, but just an extra step. I'll let it for later on. Let's get things working, and then we can really worry about setting up credentials. But I'm gonna show you how to pass the credentials when connecting. Just the Docker container is pretty much accepts everybody right now. Because I'm saying the name of the database, this PostgreSDB says the name of the database I want to create. It's gonna be called URL because it's a URL shortener. The name of the user, DB user, because I'm very creative, and the port it's gonna run. So it's the port of the container that's gonna be mapped for the port of my host. So that's the full Postgres ports 5432, and then I want to run image Postgres with the tag Alpine. Alpine is a very lightweight Linux distribution. Basically means that you're gonna have an even lighter Postgres container. If I press enter and everything works, I should have a Docker running, and I don't have because it didn't start Docker on my machine. So let's start Docker. Then system system control start Docker. Okay, should have Docker started, and then as you can see the logs from the actual Postgres instance. Nothing special, nothing that you really need to worry about. Just important to wait for the database to be ready to accept connections. Usually just take like a couple seconds. I'm gonna rename this buffer to Postgres. And okay. And then we need to create our table. So I'm gonna set another terminal and see term. And I'm gonna rename this buffer to PS. Okay, so we have a database running. Today, maybe it's not to give a lecture about SQL databases, but on database, basically need to have a table, need to describe which columns you want on the table, and then you can start inserting data. And for that, you need to connect to the database and then create the table. I'm gonna do it manually here. And I have also a command ready to connect to my database. So when you run a Docker, you can actually connect to the container and run things inside of the container. So Postgres provides this PSQL application that allows you to connect to the database and actually run SQL queries there. And that's what I'm going to be using to create the database. Later on, probably in another episode, I'm going to show you how we actually can do automated database migration. So basically when the application starts, it can check the status of the database and say, hey, does the database have all the tables I need? If yes, move on. If not, go create all the tables that need modified, the ones that need modifying, and then move on with the application. So make sure your code, your database are in the same state. But for today, let's keep it simple. Let's just make it work, and then you do automation later on. So this docker exec command, I pass the name of a container, and then the command I want to run. So basically I'm saying, go to my Postgres database, run the PSQL command with the user, DB user, and connect to the URL database. And here I have a shell for my database. And then we need to create a table to hold our data. So we have a URL shortener, and then we want to create a table. What do we need on our table? So if you remember from our code main.co, if you go to your our save handler, we can see that we save handler, we save the data directly here. With the key. So we have two parameters, key and the URL. So basically we need to store this URL and the key we generated. So what I'm doing here, I'm creating a table with 3 columns. First one is just an ID. So the auto increment numeric unique identifier to each row. So Post is going to take care of incrementing. It's going to be like 1, 2, 3, 4, 5, and so on. There's a token. So this token is actually that UID, the thing that we return to a user. So that's the short URL, part of the short URL, right? I call it token and I'm setting it as a type varchar. It means that's a sequence of characters like a string up to 50 characters long. We don't need much than that. And then there's the actual URL. That's also a string up to 2048 characters. So I was researching about the HTTP specifications, how long can URLs be. Technically, in the specification, there's really not a maximum length, but if you want to ensure compatibility with most browsers and everything, 2048 is a number that should work with most, if not all, browsers. So also to make sure that nobody's gonna try to store like a URL that's like a gigabyte long on our database, let's limit it. And that should be more than enough for us. So if you run this create table, it should create the table on the database, and it should allow us to connect to the database later and save the data. So if you press enter, of course I get an error because for some reason Postgres didn't like the comments I wrote. So just erase the comment and then finish my statement. Unique, not null. Thank you. Syntax error near varchar unique, not null. Null, there are 2 else. And I'll go to the end and run. No. Thank you, Postgres. You've been very nice to me today. No. Those column. No. Let me try to copy and paste again. Just copy it here. Actually, do different. Remove the URL. Just put it there. Don't want you. Copy. Go to the other buffer. Want to my PSQL buffer. I want line mode. Go. Yes. So we see create table. That means that it worked. So we can even do select star from URLs. And there are 0 rows there, of course. Cool. So we have a database. We have a database. How do we connect to a database in Golang? So let's first of all on our config, let's add a db con string. Let's say string and post. I'll call it db on here the same name. That should be quotable, quoted, and full, and then yeah. And also I have it here ready, so I don't make many typos. My connection strings somewhere. My connection strings here. So don't want you. One of my hands is faster than the other. Keep opening the buffer list by accident. So connection string is here. So what do we have on this connection string? We have the host. That's localhost, connected locally to my machine. And the user, as I said when I started the database, it's the DB user. The database name, URL, and SSL mode disable. So Postgres supports encryption on the connection, SSL. But as we're connecting to a Postgres on the local machine for a local application, we don't need to have SSL enabled. Nobody's going to be sniffing our traffic. So just disable it, makes things simpler. It means that when you parse our configuration, we should have access to our default configuration. So right after logger, we can do our database stuff. So if we go back to our browser, SQL package, what we need to do, we need to open a connection. So we have the open function. Open statement, where are you? No, that's not the one. Like open here. So we need to pass the driver name and the data source. So the driver name is the name of the driver. So the interesting thing about the database drivers on Golang is we actually need to import them and have them register themselves with the SQL package, so we can actually pass the driver name. So on PUQ, reference is the call package, and we should have an example here. So we import them with the underscore. That means import this package, and I'm interested in the side effects. So when I import a package with underscore here, it means even if I don't use this package, just keep it important and run like the init function of the package. And also I won't be able to actually use the package because I'm naming it underscore. And underscore is like this kind of no name thing that you can give it something, just mean, yeah, do a thing, but later I don't want to use it, but do whatever needed to be done. So when we run that, and I can try to show you the code later, it will register the driver, and then, as in the example, we can do the SQL open Postgres and pass the connection string. So let's copy that, go back to Emacs. We're back here, and that's the kind of import that Go imports is not going to be able to find because I'm not directly going to use it. So I need to add it manually. And let me copy the example. I can do that directly. If I do, I will have a database connection and an error. So SQL.open, and then the name of the Postgres dive is Postgres, and then the connection string, that's going to be your cfg.dbcon.str, and I cannot call it db, or I'd have a db connection. Okay. So db connection, we have a connection to Postgres, and so let me just start my language server. Oh yeah. Let's download the driver. So I could go get it, or I can just do go mod side and let it go to figure out everything I need. I'm only interested in the latest version, so we'll run main.go. It should break, but it's okay. But now I should be able to jump to definition if I restart my language server. And as I was telling you, the database drivers, they need function. That's the init function of our database driver that calls the SQL register and pass this name. Postgres and the driver, that's the actual driver implementation. And that's the name that we are using to when you call SQL open on our main.go. When you do SQL open, we need to pass the name that's registered there. It's usually into the documentation. So we have an error if R is different than nil. Logger.fatal error msg string not connect to database. So logger fatal, it's gonna panic on errors, so it make sure the application exits. So I'm not gonna put any return or exit statement or anything like that. One thing, I'm not logging the connection string, because in a real world scenario that would be running somewhere and would have actually real credentials like username and password that should be kept secret. So you should always be careful not to log those kind of informations. So let's not log them. If you actually running locally have an issue, then we can manually add some log debugs for the sake of local testing. But be careful not to ship applications to production that's gonna log our credentials. And now my IDE is just complaining that I'm not using the connection. So the connection is open, right? And if you jump to the documentation, let me see. So open the database connection, blah, 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 blah. So that's the important part. Open may just validate its arguments without creating a connection to the database. To verify the data source name is valid, call ping. So that's very important. So basically what it means is you can call open and get no error, and still you might not be able to connect to your database. And you're only going to discover that you cannot connect to your database when you actually try to use it. So to make sure that every time your application starts, we have a valid connection, username, password, and any other parameters you need to send to our database are valid, let's test the connection. As the documentation says, there's this ping command in the type returned that basically is going to ping the database like, hey, are you alive? So we can do dbcon.ping, and then it just returns an error. So if error is different than nil, so if I have an error, logger.error fatal error msg cannot ping database. So that makes it, yay, can't connect to the database. There's something wrong. Username might be wrong. Database name might be wrong. Anything like that. So let's see if we can open the connection. No, I don't want you buffer. Thank you. I want my terminal. go run main.go. Sorry. The server started, which means our connection is valid, right? Just to show you what would be an invalid connection, let me go to my code. I'm gonna copy that. Actually, let's go back to our code. I'm just gonna make it wrong here. Just for the sake of the example, let's try to connect to a database that doesn't exist for now. That'll be wrong, right? And not today. I want the terminal. And then you see Fatal cannot ping database. And then you see we actually have an error when pinging the database. If I try to run it with, what was the URL? Not the URL, the environment for db con str. If I do db con str equals to something like 1, 2, 3. See, you still get error on ping database. I'm not really sure I can break this connection. Yeah, I don't remember top of my mind how to make it wrong. That cannot be parsed. User equals /t. Yeah, ping database. Anyways, the open might validate, might not even validate, but the thing is we get in this cannot ping database. That's the error message we put when pinging the database. So that's basically to show you. Let me fix that and then I'll go to the code. Yeah, here. That even with a broken invalid connection string, open still returns no error. So if you don't ping, you're never sure you actually connected to the database. So unless your application might work without the database, or you actually need to wait to need the database to validate that the connection is right, ideally just open the connection, ping the database, make sure everything's working before moving on with your application, right? So we have it. And how can we start inserting data? So we have our handler, right? And our handler just have this db that actually I'm not even using the method. Great. To make it very, very simple today, and also because I'd like to keep those live streams in about an hour, let's do SQL db. That's gonna be a pointer to SQL.db. That's what the open returns, the direct connection. Later on, when you start actually structuring the code better into packages and everything, we can actually have a proper type to abstract the database. But let's just make sure we know how to use a database, we can use it, and then inside the handler, and then later on, probably 1 or 2 live streams, I'm gonna make one whole stream to refactor it, start actually writing tests, and make the code more organized. But for now, let's just learn how to make things work. So I'm initialize the handler here. So I have my SQL DB. That's my con. So we can have access to that inside the handler. I'll keep those comments there. Save URL on our handler. So it parses the URL. Sorry. And here we save the URL on our in memory. So save URL Thank you, Emacs in Sorry. And then save URL in our SQL. So it's going to be thank you autocomplete. How do we save it? We just need to write a simple SQL statement. So if you do h.sqldb dot exec context. So the SQL DB, the SQL.db is gonna provide you lots of functions to do multiple things. When you want to run a statement, like insert SQL statement, things like that, the function is exec. There are two versions of it, exec and exec context. Exec context, as the name and the signature suggests, accepts a context. If the context is cancelled, exec context will return. However, if the driver does not support context and does not support context cancellation, your statement might still be running. So be aware of that. Not because you're using exec context, you're actually canceling the statement. You need to make sure your driver knows how to do that. So it's gonna get a context and a query and argument. So we have a context. Do we have a context? No, it's not called ctx. So let's ctx r.context, not cancel. You should read my mind, Emacs. So what I like to do in most of my applications, in pretty much any HTTP handler, the first couple lines are ctx, it's my request.context, and a logger. That usually comes from the context as well. And then also if I have somehow slightly bigger functions that use the logger multiple times, I just get the logger from the context I get from the function signature. So here I need to write a SQL statement and then the argument. So let's try to write it. Insert into URL value, no, URL, the name of the columns, the name of the columns, token, and URL. So, and the values I want to insert. And now post degrees, it's, if I remember correct, is 1, 2, and then key and parasite URL. So, and just for the sake of it, column if my SQL is good enough, it should insert into the URL table, inserting the column tokens and URL. I'm not putting the ID because the ID is auto increment. Postgres is going to take care of adding it, incrementing it, handling that for me. Later, if I need to do some selecting the ID, I can use it. But to insert, I don't need it. I'm just say, hey, Postgres, go take care of it. I don't care what number it's going to be there. Just do it for me. If for some reason we need this ID later, we can actually read that from the thing we get back from exec context. Probably not going to need it now. So exec context returns a SQL.result and the error. So for now, I'm just interested in the error. And let's see if error is different than nil. And logger.error error dot msg. My Emacs is complaining for some reason. Well, cannot insert into SQL database. SQL, not SLK database. What's your problem, Emacs? SQL result and error. change to equal. Oh yeah. Yeah, it's complaining because I already have an error variable declared somewhere else, as I'm not introducing a new one as the first argument parameter. First thing here, error already exists. So it was complaining, I was kind of redeclaring it. Okay, so that should be enough to insert data into Postgres, and then we can try it. So, and then here it starts, the things start to get important, right? Actually need to return before, so I'm logging, and I need to return something. There's an arrow, turn, and how was I doing arrows? Okay, same thing. It's not status bad request anymore. Status, there's no server error. NMSG I don't need. So with sending data, this message is going to our final user. Like it's a real application, imagine. Lots of people reading it, so you need to be mindful what kind of information you send to your final user. If that's exposed to the internet, be careful not to expose the internals of your application. So one very simple thing we can do here, it's just actually send internal server error. So I can, oops, and there's a HTTP, not status text, no. There's a function status text. HTTP.status internal server. So HTTP status text just gets a HTTP status code, converts to the standard name. Look at the implementation. It's a lookup into a map. And it has got all the status codes. Oh, all of them that are officially supported. So it just, so you don't have to worry about writing it or memorize numbers and anything. And then return. So, and then of course on our logger, because that's running or on our, let's say on our infrastructure, that's a safe environment. Then you can actually say cannot insert into the database. If needed, they could even add more information. But for now, that's gonna be enough. And then let's go to your terminal. For the fools, we run, it's running, it's nice. So let's go to our browser. Get my shortcuts right. Yes, I'm getting my shortcuts right. Let's try to save golang.org. And then if you go back, we already have a error. Cannot insert SQL convert argument type and supported type URL into a struct. Cool. Request ID, blah blah blah. Main.go. It means that parsed URL is of type URL, and we need a string here. Convert that to string, save there. Let's run it again. It starts. Go back to your browser, and here in your browser, see internal server error. So your user just knows something went wrong, but you're not leaking information like, oh, I'm using Postgres. Oh, here's my Postgres credentials. So be very mindful with that. I think actually Golang is pretty good for that. Some other language that you have those huge frameworks, some of them by default are gonna print lots of information, sometimes even out environment variables, configuration, database configuration, everything that can be very dangerous if you let it enabled on production. On Go, if you just use the standard library, usually you're safer from that. And it broke again. Let's see what's the problem. Request started. Error cannot insert into SQL database. PQ relation URL does not exist. Yes, Jack. URL does not exist because we call that URLs. URLs. Yes. So let's try one more time. And now we have your new URL is this beautiful UID v4. Let's go back to our Emacs. So request is started, save the URL, request finished, right? So let's go to our PSQL just to see if things are working. So we can do a select star from URLs. And then we see we have one nice URL inserted there. And yep, we have a URL inserted there. And let's go back to your main.co. We could actually start using that. Main.co. So we can insert data into our database. I'm gonna comment out the in-memory database for now because we shouldn't be needing it anymore. Keep this log. Now our get URL. Right? If you remember, we do get, you read it from DB. So you get the key, you read requested URL from the DB here. And then if you don't have it, we have done an error. If not, we actually do the redirect. Now we need to read from our SQL database. So reading it's slightly more tricky than inserting. So first of all, we need somewhere to store the data. So we're gonna read the URL value. So requested URL. Actually, I'm gonna use the same name. Requested URL. It's a string. And let's comment that out. String. Yes. Okay. It's complaining because it cannot be nil. If len. So this thing on our database is not nullable. So let's already fix the code. If that's equals 0, I don't need string method anymore. I'm gonna add the reading code in a moment. Let's just make it compiling. Cool. So we declare it, we need to read it. So I can do h.sqldb dot query context. So the same thing as exec, we have query context, query row context. So query is the method we're gonna use to query data that can return multiple rows. Same thing, query context accepts the context because the SQL package was written before the context. So most of the functions now are duplicated and they support both versions with and without context. Query row, it's pretty much the same thing, but when you call query row, you say, hey, I'm sure that I only get one row back. So I don't need to iterate into multiple rows. I know that's only one row coming back. You can see that it returns a SQL row instead of a SQL.rows. In our case, we know we get only one. And of course, we want context. So CTX, I don't have a CTX. So CTX column equals r.context here. CTX for the logger. Sorry for my throat. CTX. What else do I need on this function? The query and the arguments for the query. Query and the arguments. Okay, so query. So I'm not gonna dive into the details of SQL today, just how to use it, of course. So select. I'm gonna be very straightforward here. So I want URL from URLs where token equals, and that should be the correct syntax for Postgres with key. So select URL from URLs where token is the parameter I'm passing here. One very important thing about the SQL database is you should not be manipulating strings, like concatenating them to add your parameters. So like the key, you should never do something like that, where token equals like plus key. and then no parameter here. Because if you do that, it's very unsafe because this key could be anything, and you're basically making yourself vulnerable to SQL injection, where someone could actually put in your argument there the whole SQL code that's going to finalize your query and run something else. So when you do like that, actually the driver and the SQL package make sure to trafficate those data without actually concatenate strings. So say, hey, that whole part here is actually a query parameter, not part of the query. So it's way safer. And what we get back, we just get a SQL.row. So let's call it row. And I need to, so row.scan. So row.scan, it accepts a list of destinations that are empty interfaces. So that basically means that you need to pass variables to read every single row, column that you selected. So on our select here, we only have one column, so I only need to pass one parameter. And of course, the scan is going to return an error. So error columns equals, error is different. It's different than nil. What do we do? So so as of now, I'm just gonna do a generic error. Let me copy paste the error code from the other one. Even gonna get the logger and fix that later. Okay. For the user, it doesn't say. Oh yeah, there's a SQL. Yeah. Okay. Scan uses the first row and discard the rest. So basically, if you select statement returns multiple rows, this row is gonna get the data from the first one. If no row matches the query, then returns error no rows. So that's very important. So what basically that means is, how do we differentiate between there's no data on the database or there's actually an error? So if the error is error no rows, then it means there's no data. So if error equals here.error and the rows, that means I don't have the data. If anything else, it means there's actually an issue. So if there's no data, that's this case, I can return not found, and I can actually do logger.info.msgf. Just put as log info, actually put a log debug. I don't want log info. Cannot find URL for token percentage Tiago S. And if you just, it's always good to actually quote strings with something when you're printing them. Key. Because if there's any blank space on a string, then you're sure where it's coming from. And then a return not found if there's actually an error. So error, I cannot read data from database. Read data from database. And then the internal server error for user. I'll keep this check here. So technically, if we don't get these no rows here, we know that, if there's no error, we know that actually data there. If for some reason there is like an empty string on the database, let's keep it for now. We're not doing any big validations when inserting, so let's be mindful of it. And then we return a redirect. So if everything's right, we should be able to actually use our SQL database to get data, to run everything, which means also if I stop and restart the application, it should always keep the same token. So if I go to my terminal, I'll stop the application, I'll start again, So if the data is in the database, everything's working. It should work, right? Because if it works, it works. So let's try localhost 3000 go string 2 this one, and it works. If go back, but if I meant to go back, request started, not errors. So just for the sake of doing that, I run once more. Just gonna run on the browser again. Thing if I can. Local Tiago localhost 3000 localhost host column 3000. Do I have it in my history? No, I don't. And go. Just keep on the terminal so you can see the logs too. And then it actually works. I got my redirect. Everything uses the database. Let me see if you actually have logs. No, I don't have logs. I mean, I have logs from the errors, but I won't get logs from the successful stuff. Let's see. I'll just try to see. I think I can set Postgres to be very verbose, but that's not the case right now. Yeah, we don't see logs on Postgres, but not a big deal. Main.go. And yeah, so basically now we have a database. It writes to our database. What's good we can do? Well, we come back to your browser. We can actually save another one. If you save HTTP, PS, and let's save Tiago.live. Let's save my website. You get a new one here. Then you can do localhost / go to, and then you land on my website. Everything seems to work. If we go back to more Emacs, go terminal PSQL, and then you select again, you see we have both URLs are working there. Everything seems to be working all right. Let's go back to our application logs and see terminal. And let's go back to our browser. Let's try to not found cases and see what happens. Host go to not in the database. So 404 page not found. If we go back to Emacs, we have the URL go to. We have the log. Cannot find URL for token, not into the database. If we actually go to the browser back and try to actually send an empty string, like go to nothing, we still get the page not found. And what we have on our logs, the same thing. We see here go to, and then find URL for token, and then because we have the quotes, it's very easy to see that's like an empty string. Let me see if I can actually put some blank spaces there. No. Let's see, percentage 20. If I remember correctly, to skip empty spaces. Yeah. So here we can see that actually you are like the token we're searching are just a couple empty spaces. So that's a nice trick. And then on URL, you have this URL escape for special characters. Blank space is percentage 20. But on the database, it gets converted to proper empty spaces. And because we quoted, it's easy to see what's actually our token string, what it's not. Let's go back to our main.go. And then I don't think I can manage to break it to show. Oh, I can break it to show an error. Yes, I can break it. I just want to show the log error to see the difference between, okay, that was not found, that was the error log error. If I go to my Postgres terminal, if I stop my Postgres container, database is shut down. I go to my application. The application is still running. The database is not. If I try to do anything that connects to the database, on my logs, I see cannot read data from the database, dial-up TCP connection refused. So it tried to connect, didn't manage to connect. And then if you go to a browser, we get internal server error and 404 page not found. It means we have a bug. Let's quickly fix that as the last thing today. We have 2 messages. It means we're not returning somewhere. Yeah, turn. So very important, every time you have HTTP handler, you handle an error, don't forget to return. So if I return here, go back to my application, try to start, the database is not there. Postgres database, docker start URL, start. Okay, it's running on the background. Terminal. That's there. It's connected. Let's stop it. Docker stop URL. So we have our application, it's running, it's connected. And I just run the request again. Like I'm gonna go to the browser. If I try again, now you only get the correct message, internal server error. And then on our logs, we actually get the real error, connection refused. So we tell to our user, hey, sorry, we broke. That's some issue. But we don't leak any sensitive information. And on our logs, we actually have all the information, like the port we tried to connect, the IP we tried, that's using IPv6, localhost, and all the details. So yeah, I said that I'll try to keep that to 1 hour. It has been 1 hour. Hope you enjoy it. For the next stream, I'm still not sure what I'm gonna tackle. Probably I'm gonna make it work more on the SQL database, refactor a bit the code, make it nicer so we start to getting into a more organized, runnable application, and maybe start automating more stuff to start and stop databases. But as you can see, we have everything we need to run our application and connect to a database. I hope you all enjoy it. Feel free to leave any comments, suggestions in the comments or reach out to me on Twitter. And I hope you all enjoy it and have a nice evening. Bye bye.